Let's do the highest common factor or HCF. We have the other name for HCF, that is GCF and GCD. Here G stands for greatest common factor. Here we have greatest common divisor. So actually what is HCF? It is the greatest common divisor only. We'll come to know how it is. So we have three methods for calculation of HCF. The first one is the factor method. The second one will be the prime factorization method, and the third is going to be your division method. So let us start the first method. In the first method we have to find out the HCF of 45 and 60. So what we have done is we have made a set A which will have all the factors of 45. So we have written down all the factors, all the possible factors of 45 in a set, and set B contains all the possible factors of 60. Now we are going to find out the intersection of both the sets, that is the factors common to both, because that is what is in the topic common factor. For the calculation of highest common factor, we must at least have the common factors first. So what is common to both? We can see it has 1 common, 3, 5 and 15 common. So that means these are the common factors in set A and set B. Now out of these common factors, which one is the highest one, or you can say the greatest one? It is 15. So we can write over here that HCF of 45 and 60 is equal to 15, because it was the highest value among all the common factors of both the numbers 45 and 60. Moving to the next method, we have the prime factorization method. Here we have to find out the HCF of 180 and 300. For this method, all we have to do is do the prime factorization of both the numbers. So we will write the factors of both, that is 180 and 300. 2 9s as 18, 2 45, 3 15, 3 5. And we have got the factors for 80, that is 2 into 2 into 3 into 3 into 5. And similarly for 300 we will find the factors, that would be 150, 2, 7 and 5, 3 2s are 6 and 5, 5 5s as 25 and 5 1s as 5. So we get 2 into 2 into 3 into 5 into 5. Now we can arrange them in the order such that we can get the powers. So what will be the powers for each? Here we can write this as what will be the common factors in all. The common factors can be highlighted separately like this. These are the common factors. Here we have 3 common and here we have 5 common. So what we are going to do over here, we are going to find out the common factors by writing them like this. So we will write that the HCF of 180 and 300 is going to be 2 into 2 into this 3 into the last one 5. Why I have done that? Because 2 into 2 was common to both. So we have 4 3s as 12 and 12 5s as 60. Why I have chosen all these? Because in out of the 2 pair common, we have taken only 1. Here 2 was common, so I have taken 1. Another 2 pair was common, I have taken 1. Taken 1 from the pair of 3 and taken 1 from the pair of 5. So here we get 60 as the HCF of 180 and 300 using the prime factorization method. Now moving on to the last method, that is the division method. Here we are going to do the basic division that we were doing, but here we will be dealing with the divisor majority. Why so? You will come to know. Let us do the first question where we have to find the HCF of 98 and 112. So I have taken the bigger number inside and the lower number outside as the divisor. Now 98, 1 times is 98. We get 14 as the remainder. Next, now here we get the previous divisor has become my next dividend and the remainder has become my next divisor. This is the divisor which was the previous remainder, and this was the divisor which has now become the dividend. Now we will again continue the division with this. Here we have 14 7 times 98 and we get 0. So this division continues till the time 0 doesn't comes. Once the 0 has arrived, you can stop your division. And for getting 0, what was the last divisor? Here we talk about the last divisor, and that is equal to 14 over here. So we can say that the HCF of 98 and 112 is equal to 14, right? Similarly, what would happen if you have to find out the HCF of 3 numbers? For that, you will be finding the HCF of 2 numbers first. Once you have got the HCF of 2, combine it with the third one and find the HCF again. You will get the final conclusion of HCF out of HCF of all the 3 ones. So let us do this. This was the first one. The second question will start with the division of first two, that is 140 divided with 105, because 140 was the larger one, so I have taken that as the dividend. On dividing we get 105 and 35 as the remainder. Now again this remainder becomes my divisor and this becomes my dividend. Now dividend is 105. Again we do it with 1 times, it will 2 less. We can try it with any number. I think it will go with 3. 3 5s is 15, 3 3s are 9 and 1 10. So I know that I have got 0 as the remainder. So what was my last divisor for this case? The last divisor for this case was 35. So I will write over here that the HCF of the two numbers, that is 105 and 140, are found to be 35. Now we have to find the HCF of 35 and the third number, which is 245. So we'll do it over here. We'll divide 245 with 35 and we'll do it with 7 because it is going directly. So now we have got again 0. So that means what was the last divisor for this? The last divisor was 35 only. So we can come to the conclusion that HCF for all the 3 numbers, that is HCF of 245, 140 and 105 is equal to 35, as it is common for both this division as well as the other division.